Hello everyone, this is Unofficial Sando. Today I'm talking about the real interview question meeting hour optimization, and this can be solved by dynamic programming. If you like my videos, you can support me by subscribing my channel. You can find the complete code of these videos and all of my video lists in description link below. The problem is pretty simple. Given a list of meeting hours, the list, each element is a meeting. And for a day, we want to take as many meetings as possible. If we only have 8 hours in totals, then the question is how many meetings we can get given a list of these meeting hours. You can pause here and take some minutes to think how you will solve these questions. All right, so I'm going to explain how to use dynamic problems method to solve this problem. There's many types dynamic problems approach. I think these problems belong to the one can be solved by bottom-up method. I'm going to use the meeting hour list and put n equal to 8 as example to explain. So two key things to design dynamic problem approach. One factor is to define the state variables. Here I define my state variable as a helper in a 2D array. It represents the max meetings we can take for the state of J hours, which means like how many meetings we can take if we only have J hours in a day. Then I is say the state of I means if we only use the first I meetings. So obviously the range of I is from index 0 to the size of H, and the range of J is from 1 to N, which is 8 in this case. Then the second factor is how to define this update function and initial function to propagate the states we have defined. In these problems, I define to update J plus HI. Basically, we just say if we take these I meetings and the states will be the J plus HI, what will equal to? Because we already know I minus 1, at I minus 1, and the J, right? So then how to propagate the state for I and J plus HI is just be plus 1 here. And we want to take the maximum one of its previous meeting hours, right? So basically, we already know what's the maximum meeting of I minus 1 J plus HI. I want to compare with the new possible solution and take the maximum one. And also this has a condition is when the I minus 1j greater than 0, because if there's no solution for I minus 1j, no mention we won't able to plus 1 for ij plus hi. And also j plus hi need to be greater and equal to n, because we don't want to exceed the constraint. So now you come to questions. Of course, we will initialize helper ij to all zeros, then when this can be achieved. So this is the initial functions come from. There's a other case that we need to initial ihi by taking the maximum of help ihi with 1, which means if we have these meeting hours in the list, for the hi state, at least we can take 1 meetings, right? So after this, we can do this update. I'm going to explain this more by going through this example. Since our state variables is 2D array, we can make this 2D table with the row as I and the column as j. So of course I is from 0 to the size of the index is 0 to 4, and j from the 1 to n is 1 to 8. Then basically we take some look how those kind of states propagate. At index 0, of course, all the elements are 0, so we are unable to do the update. We can only do the initialize to the hj, which is 2 here, and put this 1 here. Basically says we can fill our 2 hours by only take 1 meeting. Then we iterate to I equal to 2. 2 here, we also will do initialize, but it won't exceed the previous one. We still keep 1 here. And now, because I02, we already have an initial value, we can do the update part. So 2 is j, then plus hi is 2, equal to 4, and the plus 1 here. Basically says we can, by attending first and second meetings, to fill in our 4 hours in our day. So in here, we can take 2 meetings. Then we iterate to 3. We want here 3 can be initialized. 4, we still keep the previous value because yeah, we cannot take from the initial values. And only difference is that we can have the 5 because current value is 3, then 2 plus 3 is 5. Then the meeting is 1 plus 1 is 2. We also can get 7 here because we previously have 4, and 2 plus 1 is 3. And we will initialize 3 here, 1, yeah. Then we done this row, we come to fourth row, and 2, 3, I'll keep the same. We can initialize 4 here, however, the previous is 2 is bigger than 1, so we still keep 2. 5, we keep the same. But now we have 6 because previous we have 2 plus 4 is 6, then we adding 1 here, it become 2. 7, we can do from 3, right? 3, 1 plus 1 is 2, but it's smaller than its previous value, so we still keep 3. And right now we can have A now by adding 4 into 4 here. So previous 2, we adding 1 is 3. And same for the last row. So eventually, we take the maximum of this last row. We can use 7 ones or 8 ones. It doesn't matter because there's no constraints that we need to completely fill out 8 hours. We can use 7 hours as well. So the max meeting will be 3 in this case. One thing you can observe from the update function here is we always use the previous j to update the latest j index, right? So once we observe these patterns, then we can use a so-called sliding array to simplify these state variables from 2D to 1D. So basically just minimize the, remove the first dimensions. Let's see how we do that in the real code. So here I have help functions, only have 1D, 1D just in the J previously. I plus 1 here because I don't want to use 0 index. So I plus 1 here. Then what happens here is first I iterate all the meetings in the meeting hours. So this is the I iterate I. Then the difference is that I found the maximum hour constraint to the smaller one, so that I can use my previous values, right, to here to hold the previous I. Then we do the update here. So I hope you understand this, how to use this sliding arrays mindset to reduce the 2D array to the 1D array. Basically, we use this previous value to contain the, say, the helper I minus 1 j's values, because we will update these helpers I j value later. We can use this to temporarily hold the previous rows values. One thing you need to be very careful here is we need to do this initialization later, not earlier. Otherwise, it will mistakenly to make our update functions going wrong. So here we put the initial function later because we're using this sliding vectors idea. Then eventually we finish this true for loop. We just return the maximum elements from our order solutions here. So here I also given a test case. You can test your code. So lastly, let's analyze the complexity. For computation complexity, say if we have n meetings and m is the hour constraint, basically we are doing this for loop and iterate one by one. So it's big of n multiply m. The space complexity is big of n because we allocate this helpers array. Then say as our previous mentions, if you use 2D, then it's big of n multiply m. So by doing the sliding array ways, we can reduce the space to the 1D. So I feel like maybe it's still kind of some confusing point, even I go through all the dynamic programming process. So I would recommend you could just follow my previous 2D tables and try to do some iterations. So I think you can feel better. Also, for this sliding arrays method to reduce the dimensionality, you also need some practice to understand. So I'm going to bring more dynamic programming's problems to help you cracking the different type of problems later. But that's all I want to today for these problems. Then see you in next video.